Okay. Can you hear me?
Yes po.
Okay.
Yes, sir.
So tell me if my connection is low or if I'm choppy. So I hope you can read or see the screen well. So I will just be giving 3 exercises. 2 will be demonstrated, but the last one will be for seat work before I discuss the solution. So let us start with that inequality x is greater than x cubed. Now you do not solve this inequality by dividing both sides by x, since you are not sure if x is positive or negative. That means it depends on the case. You have to do cases if you try that method, but it still won't work since some of the solutions may be lost in the process since it involves division. Okay, so never ever divide an inequality by a variable. Okay, you can divide by a constant or a real number, but not by a variable. You can only manipulate it either by transposing, factoring, and adding. Okay, you can add, multiply, divide, subtract by a real number. Okay, you do not divide an inequality by any variable expression. Okay, so how do we solve this one? Okay, we have to transpose everything first on one side of the inequality. You can do it on the right hand side, but let me do it on the left hand side. So I'll be transposing x cubed. So the inequality becomes x minus x cubed greater than 0. The sign chart method is the one that we will be always using when solving polynomial and rational inequalities. So that means you always have to have a 0 on one side of the inequality, and you do not have a 0 on either left or right hand side of the original inequality. So you need to transpose terms first. Once you've done so, you construct a sign chart for the expression appearing on the non-zero side of the inequality. And most of the time, okay, if not most of the time, sometimes the expression might not yet be factored out. This one is not given in factored form, unlike the ones we've discussed in class. They were given already in factored form. And since this involves transposition first, so you know that you eventually have to factor out the expression, okay, on the one side of the inequality. Now, a basic knowledge of factorization of polynomials, or what they call this, at least quadratics, okay, is presupposed in this section. Now, this is cubic actually, but it can be factored out by first taking out or factoring out the GCF, which is x. So if I factor out x first, we will get the equivalent inequality x times the quantity 1 minus x squared is greater than 0. And the expression left inside the parentheses is quadratic, which can be factored out usually by trial and error. But this one is just a difference of 2 squares. So most of you know that it factors into 1 minus x, 1 plus x. Okay. so that there are three factors present, meaning there will be three critical numbers, or rather partition numbers. What are the partition numbers? If you read the module in advance and also viewed the lecture, the video lecture on this, the partition numbers are those values of x which make either the numerator or the denominator zero. In other words, the zeros of all the factors appearing in the expression. So there are three factors, and they are all linear. So there are also three partition numbers, namely, okay, let me use different color for the real line. There will be three factors. So they will be the partition numbers, namely -1, 0, and 1. They are just the zeros of the three factors present. If you equate each to 0, you'll get those partition numbers. And then if they are on the numerator, they will actually be zeros. But if they are on the denominator, they will make the expression undefined. So you put ND, right? I'll give an example later where you put an ND. But since they are all on the numerator, no divisor here, except 1, of course. So we put 0 on top of all those, partition. Lagi ko na gagamit yung critical. So partition number. Put a 0 to remind you that if you plug in -1, 0, and 1, the expression becomes 0. And then you pick a test number for each interval. So let's start, let's say, with the rightmost interval. I'll pick 2. 2 is here. And if I plug in 2, so notice you'll get 2 times 1 minus 2 times 1 plus 2. Actually, you need not compute the exact value. You just consider the signs of each factor. So positive, negative, positive. And that means it will be negative in that interval. So I put a negative sign here to indicate that the expression here is negative also throughout that interval. In fact, you can use any other test number. You will always get the same result. The sign will be unique. Okay, it's not possible to get two different signs there. So you just need one. And then you do it for all of the intervals. So let's demonstrate for this particular example. So you pick a number here. So there's no whole number there. So you have to use a decimal or a fraction, 1/2 or 0.5. Now you can do a mental computation since you only need to consider the signs. So if you plug in 0.5 here, okay, you'll get positive 1 minus 0.5. So here is positive. 1 plus 0.5 is positive. So you get a positive. Okay, for the next interval here from the right. Oops. And then you do it again. So pick negative 0.5. It will be negative. 1 minus negative 0.5, positive. 1 plus negative 0.5, positive. So it will be negative. And then you plug in for this interval, -2. So negative, positive, 1 minus -2. 1 plus -2 is negative. So two negatives make a positive. So positive. Okay, the signs do not always alternate, by the way. Just So happens here that the signs alternate. Okay, so that's the sign chart. And it tells us where the function here, or rather the expression here, is positive, where it is negative, and where it is zero, and where it is undefined. And now you can solve the inequality using that sign chart. So you want the expression to be strictly greater than zero, that is positive. So you look for the intervals where it is positive, you exclude the partition numbers. They are not part of the solution because the function becomes exactly zero at those values, unless there were an equal to in the inequality. You would have to include them. So they are excluded, so we just write, okay, these are the two intervals that we need to pick for our solution set, and we write our solution set in interval notation. So we have solution set negative infinity to -1 open, union 0, 1 open interval. Okay, so that's the final answer. And of course, if this were an upload file type of problem in the exercise or the quiz, then you would have to show the sign chart to get partial points and the full credit eventually if you get the correct answer as well. Okay, so is there any question on this? I cannot view the chat box for now. I'm using a tablet, so any question, just freely unmute your microphone. You can speak.
I have po.
Otherwise, yes.
Sir, di ba, okay, I tried doing it din kasi, pero I transposed x to the other side.
Pwede rin yan.
So it's the same lang din naman po. So okay lang.
Pero ang hahanapin mo na negative.
Yes po.
Ang magiging sign chart mo, babaliktad lang naman yan. Actually, pag ito ang ginamit mo, babaliktad lang yung signs. Magiging ganito yan actually. Tapos ang hahanapin mo, negative din.
Yes
So yun
po.
pa rin ang kalalabasan.
Apo, yun po nakuha ko. Thank you.
So, isang munang illustration pa, and then isang practice, that's it. Now, yung mga mga practice exercises doon, kung may tanong kayo, for consultation na lang yan. Okay? So, sometimes the signs do not alternate, as in this example. So, it's already, in fact, almost factored form, except that the denominator has to be thoroughly factored out. So we do that first before we construct the sign chart. The numerator has no problem. So only the denominator needs to be factored out. And you know that x squared minus 4 is a difference of 2 squares. X plus 2 times x minus 2 then will be its factorization, and it's squared. Or you could have directly written x plus 2 squared, x minus 2 squared. Okay. So why do we need to do this? So that we know what the partition numbers are. If you only look at this one, you might think the partition number is 4. Or you would just equate this to 0 and just get 2, when in fact there are 2 partition numbers that it will give, namely -2 and 2, as evident from the factored form here. So let's construct the sign chart. First, the partition numbers. Again, there are 3, although you have degree 2, degree 2, degree 1, so degree 5, but though there are technically 5, okay, but some of the zeros or roots are of multiplicity 2. Okay, but we just put in those three partition numbers, -2, 0, 2. And then before proceeding to determine the signs, put first whether you have a 0 or an ND. ND means not in the domain, or sometimes not defined there, not defined. Or sometimes I just put an N para hindi na isusulat lahat. Pero dahil yun yung nasa textbook, so where do we have a 0? On the numerator. So lahat ng zeros ng numerator, yun yung pagbibigay ng 0. And then all the zeros of the denominator will give us an ND. Because if you plug in those numbers, the denominator will become 0 and you cannot divide by 0. And so now we can construct the sign chart. Isa-isahin natin ulit. So, actually, isang sign na lang ang kailangan para sa lahat, pero isusulat ko yung isa-isa, no? Pag pinalag in. Now, if we pick a test number here, say 3, all will be positive, obviously. So X will yield a positive value. And then this one will yield a positive value. Really no need to write it as divided by, since it won't affect the sign. So let me just write a series of signs. So positive, positive, positive. So we eventually get positive. Okay. Now it should be obvious that since these are squared, then we will always get a positive, right? So actually, you just need to determine the sign of this one. But anyway, let me write down all the signs. So let's plug in 1 from this interval. So if you plug in 1, still positive, 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 so positive. And then plug in -1, will be negative, positive, positive. So you'll get negative. And then plug in -3, you'll get negative, positive, positive. So you have negative. So the signs did not alternate. Okay, so negative, negative, positive, positive from left to right. Okay, and so we know where the function or where this expression is positive, where it is negative, where it is not defined, where it becomes exactly equal to 0. Now, we want the expression to be less than or equal to 0. So we include those partition numbers where we have a 0 on top. So that means this will be part of the answer. So less than means negative. But since we have an ND, we have to separate the two intervals there. Although we have negative both in those intervals, but we write the solution set as -infinity to -2 open, union -2 to 0 closed. Any question? Okay, so I'll give you 10 minutes to work out this last one, and then I'll go back, but I'll just be here. If you have any questions, okay, just send a message in the chat box. This one here now. Now, just a hint, you transpose 2 first to the other side, and then you will need to simplify yung LCD gagamitin, and then you'll soon see that the numerator has to be factored out. So eventually, magkakaroon ka dyan ng tatlong partition numbers. Okay, so 10 minutes. Okay. So I don't know where you are at now, but I hope you've at least factored out correctly the expression. Let me show. So if you transpose okay, you get this. And then you have to use the LCD to be able to rewrite that as this. Do not multiply by a variable, like you multiply everything by x plus 12 so that x plus 12 will disappear. No, that will be wrong. Rather, you simplify the expression first. And then the numerator will become x squared minus 2x minus 24, which is factorable. Factors of negative 24 that add up to negative 2 are negative 6 and 4. So you have x minus 6 times x plus 4. Okay, you add negative 6 and 4, you get negative 2. Then you multiply negative 6 and 4, you get negative 24. So that's correct. Then the rest is just as usual, sign chart. And let me just show you the sign chart without having to go into the details. So the partition numbers are negative 12, negative 4, and then 6. And the at negative 12, then zeros at negative 4 and 6. And then the correct order of signs, plus, minus, plus, minus, from right to left. So we have solution set. Okay, greater than or equal to 0. So negative 12 open, negative 4 closed, union 6 closed, infinity. Is there any question? So in other words, you do algebra first and then the sign chart method to solve the inequality. Now, in my next class, I will be giving practice exercises on inequalities involving absolute value. Okay, which I will also be uploading to your Canvas so that you will be able to also study them. And then tomorrow is the start of the graded exercises, right? 1A and 1B, they will be open, but you need not answer them, of course, tomorrow. You have until July 8th to answer them. And by Wednesday, I think you should answer first exercise 1A since they are just on inequalities. And then you reserve answering 1B for perhaps Thursday since I will be discussing on Wednesday. Now, I might, what do you call this? Extend the deadline of exercise 1B for another day due to us not having, not being able to have classes last week, last Wednesday. Okay, is there any question? So that's pretty much it for today.
Peter.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.